first line, you want to find x and y intercepts. So to find the x-intercept, you're going to plug in a 0 for y. So by plugging in a 0 for y, this whole term goes away, and you're left with 3x equals 12. So if 3x is equal to 12, then that means x has to be 4. So that's your x-intercept for the first line, 4, 0. You can graph that down here, 1, 2, 3, 4, 0. Then you're going to do the same thing for y. So to find the y-intercept, you're going to plug in a 0 for x. So by plugging in a 0 for x, this whole term goes away. You get 2y is 12, okay, when this term goes away. Divide and you get y equals 6. That's your y-intercept. Go up 1, 2, 3, 4, 5, 6, put in your y-intercept. So then you're going to graph this line and shade. To see where it's shaded, you want to plug in zeros for x and y, and then see if it's true or not. So is 0 less than 12? And it is. So if it's true, you're going to shade towards 0, 0. So we're going to shade in this direction because it's true. 0 is less than or equal to 12. To graph your second line, this one's in slope-intercept form. So when it's in slope-intercept form, you're just going to use the y-intercept and the slope. So your y-intercept is 5. That's this guy right here. So that point is here, 0, 5. And then you're going to use your slope. So we can't really see the slope, but we know it's going to be -1 over 1 because of the negative sign. So from this point, we're going to go down 1 and to the right 1 and put a point. And if you want, you can continue doing that same slope, and that way you can see where the pink and this blue line are going to intersect if you keep doing the slope of down 1 to the right 1. Because this is in slope-intercept form, we can just shade up or down. It says y is less than. So the y's are getting less than when you go down. So we're going to shade below the blue line. The third line is x is greater than or equal to 0. So that is a vertical line going through 0. Okay, so remember, x equals, those are vertical lines, and they get greater to the right, because this is where x is 1, and this is where x is -1, so the x's are getting bigger as we go to the right. The fourth line is y is greater than 0, so y equals, those are horizontal lines. So y is greater than 0 is going to be the horizontal line going through 0. Right here. And again, it's getting greater. So above is where the y's get greater. The very last thing you want to do for this question is shade the feasible region. So that's where all these arrows are pointing. All of the arrows are pointing right in here in this quadrilateral shape. Okay, so this is your feasible region. So that would be the graph of the inequalities. Now, part 2 is to answer these questions over here. So these two questions are related. So after you graph it, you're going to list your vertices. Your vertices are the points that enclose the feasible region. So 1, 2, 3, 4. Those are your 4 vertices. Okay, so you're just listing them. So the top point over here, that is at 0, 5. This is at 0, 0. This is at 4, 0. And this one's at 2, 3. If you can't tell where the pink and the blue are intersecting, then you would take your blue line and your pink line without the inequalities, and you would solve using either substitution or elimination. So to solve using substitution or elimination, this one would be easier to solve using substitution. You could just take this and plug it in for y. Okay, and then you would distribute the 2. You can combine these two and then subtract 10 and you get x is 2. Then you can plug it back in and that's how you get that y is 3. Okay, so that's just if your graph, if you can't tell where they intersect on your graph. If you can see where they intersect on the graph, then you don't have to do this. To find your maximum, you're going to take each one of these points that you found and listed, and you're going to plug them in. Make sure you're plugging the x's in for x and the y's in for y's. So plug in 0 for x and 5 for y. You get 25. Here you're plugging in a 0 for x and a 0 for y. So you get 0. Here you're plugging in 4 for x and 0 for y, and you get 12. And here we need to plug in 2 for x, 3 for y. This is 6, this is 15, we get 21. Okay, so that means that your maximum is the biggest number over here, so 25, and it happens at the point 0, 5.